Hello, everyone. This is Gao Jian. I'm very glad to be here and share my research findings at Black Hat Europe 2022 today. Really appreciate the privilege. The topic I would like to share today is fuzzing and breaking security functions of SIMATIC PLCs. Okay. Before I begin, I would like to introduce myself real quick. My name is Gao Jian from Xi'an, China. Currently an industry control system security researcher and NF focus. The research mainly focuses on PLC, DCS, SCADA, industrial equipment, and system. Working includes things like vulnerability discovery, industrial field security testing, and evaluation. For the past few years, I reported several vulnerabilities to Siemens, ABB, Schneider, and so on. Got dozens of CVEs, and of course, text notes from these complaints. As well, I have shared my research and several conferences. These include HITCON, HITB AMS, HITB Singapore, ICS Cyber Security Conference, China, Kench SDC, KingCon 2022, and so on. If you have any questions or ideas regarding the security aspect of industrial control system, please feel free to contact me. Here is my email. I'm looking forward to your emails. Please allow me to introduce our lab, Global Lab, which focuses on SAIs, IoT, and Internet of Weakness-related security issues. So here is the outline of today's presentation. First of all, a brief introduction to the SS architecture, PLC concept, Siemens SIMATIC PLC, and previous related research. The second part introduces some security design and functions after the release of TLS 17, such as security wizard settings, configuration data interruption, communication protocol interruption, and so on. Next, we will explain the TLS-based S7 compliance protocol, including how to enable TLS secure communication, what is the protocol like, how to obtain the plain TLS package, how to create a rogue client to control the latest version of S7-1200 and S7-1500. In the fourth part, the access protection which are used to prevent unauthorized access in the firmware of TLS 16 and S7-1200 waveform punch form can be bypassed using pass-the-host method. In this part, we analyze whether the access control design of TLS 17 and the latest firmware version can be bypassed. The next part will be the most notable part of this topic. In this part, we will introduce how to conduct fuzzing tests for SM compliance, TLS protocol step by step, and introduce each process in detail, including cyber making, mutation strategy, anomaly detection, building automatic fuzzing platform, and so on. And last but not least, we will introduce how to purchase SIMATIC PLCs, summarize relevant issues, and point out possible research directions for this subject in the future. Okay, let's get started. Industry control system is a collective term used to describe different types of control system used for industrial production, including SCADA system, distributed control system, and programmable logic controllers, which are widely used for the industrial sectors and critical infrastructure, such as power plants, water facilities, transportation systems, chemical plants, food and agriculture, automotive manufacturing, and so on. Okay, in the production mode, we are usually most concerned with the manufacturing zone, which is the place where all the actions are controlled and executed. Being bridge between the physical world and the IT world, the manufacturing zone is the core part of the whole production mode. And showing the red diagram, it's obvious that the core is the controller, which is connected with the sensors and actors. In this case, the controller is the core of the production mode. Normally, controllers include DCS, PLC, RTU, and so on. But in our topic today, we are talking about PLC in particular. A PLC is a industrial digital computer that has been registered and adapted for the control of manufacturing processes, such as assembly lines, robotic devices, or any activity that requires high reliability, easy of programming, and process fault diagnosis. Their members are vendors, but Siemens PLC has the largest market share in the global market. Siemens PLC is used in a variety of complex and harsh industrial environments, and it has been prized by customers for its excellent performance. That's part of the reason why we start Siemens PLC. Okay. SIMATIC is a PLC produced by Siemens for industry. The latest series now is S7, which has been the most popular PLC in the market and used in areas of critical infrastructure. The first inches in S7 line were released in 1994. Available product range and shown on the right. This includes the feedback-based S7-300 and S7-400, and the new generation of industrial insight-based PLC series, including the S7-200 Smart, S7-1200, and S7-1500. The new consumer television SIMATIC PLCs S7-1200 and S7-1500 has an up-to-date system architecture. The new generation consumer adopts the latest communication protocol S7 Plus with integrated check TLS 17, which was released in May 2021, together with the latest version of the firmware, are designed to use a communication protocol with TLS. Okay. A lot of efforts have been put on SIMATIC S7 PLC research in recent years by many researchers, and many results come out. This will help Siemens improve their PLC security and make more reliable products. The previous research was based on TIAV16, which doesn't have the enhanced security design by nature. Our new targets are newer versions like with 2.9 for S7-15, which comes with the enhanced security design. There are four research goals. One, to get the latest in TLS traffic and compare it to the older protocols. Two, to construct a root clinch so that we could control the PLC with newer firmware. Three, to discover vulnerabilities of this enhanced SIMATIC PLCs quickly and build a Fuzzing platform. And four, how to exploit this SIMATIC PLC with enhanced security features. Before we dive into these four goals, let's have a look what enhanced security features Siemens have. Firstly, their security protection for configuration date. If user enable this option and set a password, the data in configuration software will be protected from the theft or tampering. Secondly, the enhanced communication design with this new feature enabled. The communication will be based on TLS secure protocol. This could prevent traffic sniffing and sensitive information leakage. Thirdly, there will be a security wizard when creating a new project field, and it will guide users to enable necessary security options, like security, communication, access protection lead. And these two features will be the main focus in today's talk. Now, let's see how to enable the secure communication option. To start with, we create a new project and only enable the secure communication protocol option. Leave the reset options just for now. Save the project and load it into the target PLC. Trust the PLC and constructing communication bits. We then use VLSHA to capture the traffic so that we could see the communication between the client and PLC. For the traffic, we know that there are several steps in this communication that are fixed. First, TCP connection will be established, followed by the COTP connection, and then the client needs to initialize SSL to ensure the secure communication, and then comes the encrypted TLS traffic. Okay, Here is a traffic stepper. We can see that apart from the encrypted TLS part, we have a COTP part in the header. We now call this protocol S7 plus TLS. We can't analyze the encrypted TLS traffic, so how can we get our hands on the plain text? Okay. There are many ways to do that, like hook or decrypt it with the private key. In our research, we did it with hook. First, we analyzed the OMSP core managed.dll field and located the functions before encryption and after decryption, and then dumped the package to get the plain text. We have managed to capture the traffic of stock PLC into different configurations. Let's have a look. We can see that S7 plus TLS uses the V2 protocol version and removes the integrated part, the 33-byte part, and the security of communication is fully guaranteed by TLS. Now that we are clear about the plain text message of S7 plus TLS protocol, we are able to make a root client to control the PLC. We use the method and show in the diagram. We first obtain the plain text message, then added SSL SSL to the plain text message and finally added TPKT and COTP ports and send them to PLC with the help of proxy. When the PLC responded to the message, we just reverse the process. First, the TPKT and COTP ports are removed, and then the plain text response message is obtained by decrypting the SSL message. The complete process is shown in the diagram on the right. To implement a root client using Fuzzing, you need to go through the process of TCP connection, COTP connection, and SSL initialization and TLS state interaction. Okay, it's demo 10. Sorry. Okay. Let's look at. This is the reply attack demo. We use the latest version of the firmware. The firmware in S7-1500 PLC is V4.6.0, and another firmware is V2.9.4. Okay, now we can see it. We can perform run and stop to S7-1500 PLC. And see another demo. We can use root client to control S7-1500 PLC. Also can perform stop, run. Okay. This demo only shows running and stop operations, but more can be performed, such as downloading programs, reading and writing variable values, and uploading projects, and so on. Let's continue. To prevent unauthorized modifications or sensitive operations, Siemens design access control features that, when enabled, can block merely attacks, including reply attacks, PLC bluster attacks, read-write value attacks. However, most of the time, users don't enable it, thus introducing a lot of security risks. With TIA V16 and S7-1500 V4.4 firmware version, it can be bypassed even if access protection is enabled. Let's take a look at how to do that. For PLC, the password is stored in hash form without further encryption, so we can obtain the hash value of the password using memory jump or desoldering flash chip, and then use the parse hash method to bypass the access protection lead. So now, what about TIA V17 with the latest firmware version? Is it possible to bypass it? We further investigated the issue and found that the new variant of the password had been processed in the PLC using the PBKey-2 derived secret key to protect the password hash. Therefore, unfortunately, the old method won't work anymore. During authorization, the XOR algorithm is used to encrypt the password hash value. However, this algorithm is very simple. Attackers can obtain the password hash by sniffing TLS traffic and decrypting it. So far, we have talked about the enhanced design and secure communication, but how to attack a PLC with enhanced security protection enabled. That proposes many changes, such as not being able to use the previous method to bypass access protection, and secure communication is protected by TLS. The previous research method is no longer applicable to the latest version of the enhanced SIMATIC PLCs. So, we adopted the most popular method of vulnerability discovery, Fuzzing testing. Next, we will explain in detail how to perform the Fuzzing test for the enhanced security PLC. Here, we will explain step-by-step the methods of setting up Fuzzing test environment, including segregation, mutation strategy, malware detection, and so on. And the S7 plus TLS is a complex protocol which is the Fuzzing module based on mutation. First of all, we can do some tweakings on the replay attack script, such as replacing a single batch or multiple batches with special values, and then assemble a new message and send it to PLC to say what will happen. This is the simplest single separate fuzzing test mode. Mutation-based fuzzing needs servers, and to some extent, the rich list of servers determines the number of vulnerabilities. There are two methods to make servers. The first one is to perform various operations on the client TIA we sent in, such as downloading, online, checking, formatting, and so on, and then capture and save the plain text message of these operations to build the funny fuzzer field. To make the server richer, we also need to reverse and engineer to S7 plus protocol. We need to foundation code instruction mutation. The goal is to mutate the date part of S7 plus protocol. After the mutation, the date length part needs to be fixed. We combine various mutation strategies. Mainly AFL, Redensa, and some customers want to build a mutation strategy engine. We randomly select servers from the corpus and send to the mutation engine, which then randomly select the mutation strategy to carry out the mutation output on the sent servers. Okay, we also need to pay attention to the target status during the whole fuzzing process. When the target enters and failure status, like protocol stack crashing, not being able to respond to the request, error LED lights up, and so on. Well, how can we find out this kind of abnormal results? We can send a special S7 plus request to target PLC to check if stack exceptions, or use a third-party module to acquire cyclical signals from the test target PLC output to check program exceptions, or use the third-party calculation module to acquire the voltage signals of the PLC error LED to check PLC to see if we reach a defective state. Okay, with the three most important steps covered, we need to set up a platform to perform fuzzing testing. As shown in the diagram below, we use Python to write the fuzzing test script. The main components of the script include S7 TLS OpenCon, Fuzz engine, message recording and repair module, SSL, processing module, socket proxy module, exception detection module, in addition to the several fields made earlier. By writing these partial functions and making them into a fuzzing test platform, we can now go test the target PLC. However, there is a problem. For example, when the target PLC crashes, this fuzzing process will end. How can we solve it and continue the next round of the test? Here, we use the power control unit to help target PLC reset to do that. The diagram shows the automatic fuzzing test platform. In addition to the mutation part, the detection part, and the communication part, the power control part is also added. The fuzzing process of the overall fuzzing test platform is shown in the flowchart. First, the plain test message or result analysis protocol is used to make several fields, and then the samples are sent to the main program. The mutation engine performs mutation operations, and then the samples are sent to the target PLC. This process enables automated fuzzing testing. The test platform is not only suitable for S7 complex TLS, but also with modifications for other protocols such as UMAS and CUDASYS V2 and V3. This is the fuzzing test platform we built. We can clearly see that the target PLC, detection module, power control unit, power supply, and how to make error LED light detection. Okay, it's also demo 10. This demo based on the above-built fuzzing test platform. We use the platform to test the latest version of S7-1500. The version is v4.6.0. Okay, it's working. Wait a moment. Okay, when the arrow LED light is on, the authorization message will be recorded and the program will automatically reset PLC to start the next round of fuzzing tests. This greatly improves the efficiency of the whole fuzzing test. You can see the continue. Okay, let's continue. Since August 2021, we have submitted several SIMATIC PLCs vulnerabilities to Siemens. After investigation, reproducing, and fixing the vulnerabilities, Siemens issued a security evaluation for 3 of these vulnerabilities on February 8, 2022. Siemens is still investigating the remaining vulnerabilities and planning to address more of them in December 2022. Because these vulnerabilities S7 Plus crash, and they may cause serious consequences, such as remotely denial of the voice for SIMATIC PLCs, although you enable access protection D. 2 of 3 addressed vulnerabilities have a wide impact and can be successfully exposed if the access protection is enabled. In particular, CVE 2021-37204 fetch a wide range of products, including firmware that only support S7 complex V3 protocol. Therefore, we chose to analyze this vulnerability. We found out it results from 2 factors, one being the change of bit 0 in the transport plan part of the package. When bit 0 is 1, it's an exception. The second being that the next condition is quickly corrected after the abnormal package is sent. This will cause the program to use the uninitialized memory value and the function address in the process, which will cause the PLC to crash. So, how does Siemens fix it? we compare the functions before and after the patch and found out that there is an extra if statement to check for abnormal package and collection status, which ensures that the PLC will not crash even if it receives abnormal packets. How to protect the customer's SIMATIC PLCs? Here are some suggestions. First, following the vendor's recommendations, upgrading to the latest firmware if possible. Second, users perform the best practice to minimize the risk or exception of these vulnerabilities. Construct a deep and vertical defending structure. Third, pay attention to security management. All operation or maintenance personnel need to be audited. It's worth nothing that there is no relevant security product supporting the S7 complex TLS protocol. So customers should pay more attention to the security of SIMATIC PLCs. Okay, so let's conclude what we have talked today. First, compare to S7 complex V3. Latest security protocol use the V2 version. Second, attacker can construct scripts to perform replay tests targeting S7-1200 and S7-1500 with the latest version and conductive actions like run, stop, uploading projects, downloading projects, and so on. Third, provide a detailed introduction of Fuzzing S7 complex TLS protocol, including the method of creating tables, mutation strategy, anomaly detection, power management, building automatic Fuzzing platform, and so on. Fourth, the security of the latest protocol may depend on TLS. Okay. Starting from this project, there are many future work and independent research we can do, such as more in-depth research about server generation aiming to enrich the path coverage. Second, more in-depth research about mutation algorithms that are more effective and intelligent. Third, research on Fuzzing methods with the feedback and path coverage features targeting SIMATIC PLCs. Fourth, research on debugging SIMATIC PLCs aiming to facilitate quick analysis of vulnerabilities, which can also be combined with EFL to achieve security testing. This allows you to dive deeper into the code and find more vulnerabilities. Okay, that's all for today's presentation. Thank you for joining the talk. If you have any questions, please feel free to contact me. Here is my email. I'm looking forward to hear from you. Thank you.